Hi everyone, and welcome back to Genealogy and Decoding Your Y-DNA, a series about how Y-DNA testing can help us explore our paternal lines. My name is Jeremy Lehman, and I am a genealogist who loves weaving DNA into family history research. Be sure to check out a link to all of the videos in my Decoding Your Y-DNA series in the description or down in the comments. And if you're enjoying the series, I would love it if you subscribed to my channel. In this video, we'll take a look into the future and see how the Y-DNA landscape might evolve over the coming years. To best understand where we may be headed, it is helpful to review where we have come from. The history of Y-DNA research extends back more than 30 years. During the 1990s, academics and forensic investigators first began using Y chromosome STRs and SNP mutations in their analyses. And in the year 2000, Family Tree DNA became the first consumer-facing genetic genealogy testing company, initially offering a 12-marker Y-STR test and a mtDNA test. In the years that followed, Family Tree DNA expanded its Y chromosome STR panels, increasing to 25 markers, 37 markers, 67 markers, and eventually to 111 markers. The next big innovation to come to Y-DNA testing came in 2013 when Family Tree DNA first introduced its next-generation sequencing technology, better known as NGS. It was at this time that they first offered a big Y test that allowed for scanning of huge regions of the Y chromosome in order to discover new SNPs. This was expanded on in 2019, when Family Tree DNA began offering the Big Y700 test that remains on the market today. The Big Y700 test greatly expanded the SNP and STR coverage, and it led to an explosion in newly discovered SNPs, leading to detailed phylogenetic trees that extend into a genealogical time frame. Despite this long history, Y-DNA testing remains a small market. For many people, taking a Y-DNA test will not initially yield any connections within a genealogical time frame due to a lack of testing breadth. There still are so many more surnames and families that need to be tested. So where is the Y-DNA testing landscape headed? Here are 3 predictions that I have for how Y-DNA testing will evolve over the next decade. Prediction number 1. Ancient DNA will play an important role contextualizing the earlier history of paternal lineages. Ancient DNA refers to the genetic material recovered from the remains of humans that lived in the past, anywhere from hundreds to tens of thousands of years ago. Due to technological advances, there has been a flood of new research papers devoted to ancient DNA samples over the past decade. If you want to learn more about ancient DNA, be sure to check out my video on the subject. There has been an interesting convergence in recent years that I think will have major impacts on Y-DNA research in the future. On the one hand, there is more and more research being devoted toward ancient DNA samples. These studies are mainly focused on autosomal DNA research, as autosomal DNA provides a more comprehensive look at a sample's DNA. But there is now a greater recognition among the research community about the importance of also studying the Y-DNA haplogroups of ancient DNA men. More and more, I am seeing that researchers are providing detailed terminal haplogroup assignments for the ancient DNA male samples, and not just a high-level upstream haplogroup. Scientists are utilizing family tree DNAs and Y-folds phylogenetic trees to arrive at this more granular haplogroup assignment. So what does this mean? As more of these studies get published, we should see more and more ancient DNA samples with precise Y-DNA haplogroup assignments. And over time, this will provide important context to paternal lineages. Imagine you're a new tester receiving your Big Y results. You get your assigned terminal haplogroup, which you can view on the Big Y block tree. But in the not too distant future, you might also be given some commentary about your upstream haplogroups. Perhaps family tree DNA will tell you that 500 years ago, there were men carrying your upstream haplogroup that lived in England. And that 2,000 years ago, men carrying your haplogroup were living in Italy, in the Roman Empire. While ancient DNA will not necessarily be able to determine that these men were your direct ancestors, it can give you greater contextualization for where a paternal lineage has existed in human history. We are able to recreate such histories for a select few lineages today, but the potential is for this to expand to many more lineages in the coming years. Prediction number 2. Whole genome sequencing could be a catalyst for more widespread adoption of Y-DNA testing. Whole genome sequencing, or WGS, is a method of DNA testing of all 3.2 billion base pairs of a person's DNA, including autosomal DNA, mtDNA, and X and Y chromosomal DNA. It is pretty remarkable that such technology exists today. A little more than 20 years ago, the Human Genome Project wrapped up a Herculean project spanning more than a decade to map and sequence a single human reference genome. The project is estimated to have cost upwards of $2.7 billion. Fast forward to today, and WGS tests are offered by many different companies, ranging from a price of less than $100 to up to a few $1,000s. The wide disparity in price is due to a variety of factors, but most notably the coverage level of a WGS test. Coverage refers to the average number of times each base in the genome is independently sequenced. A 10 times coverage test means that on average, each base in the genome was read 10 times. And a 30 times coverage test means that on average, each base in the genome was read 30 times. The cost of a WGS test increases the higher the coverage level. You might be asking, why would you need a 30 times coverage WGS test in the first place? Well, the reason is that sequencing can result in errors. You want to have as many reads as possible for every base in order to be sure that you are recording the correct value. In general, a 30 times coverage test or higher is considered clinical grade, meaning that it can be used in medical diagnostic testing. The main use today for WGS testing is for medical purposes. Testing your entire genome can help with medical diagnosis, disease risk interpretation, pharmacogenomics, and rare disease evaluation. As our scientific knowledge of DNA has grown, we have learned that our genome's influence on our health is really complicated. We can't just look at a small part of the genome in the hopes of understanding its impact on human health. Instead, we need a holistic approach that looks across the entire genome. Whole genome sequencing is an advancement over the technology of SNP genotyping arrays that has historically been used by the consumer-facing DNA testing companies. Companies such as Ancestry and 23andMe only look at about 700,000 base pairs of your DNA, compared to the more than 3 billion base pairs in your entire genome. That's less than 0.05% of a person's genome. This is much more cost efficient compared with WGS testing, and is sufficient in most cases for providing ethnicity estimates and creating an extensive DNA match list for testers. Since SNP array genotyping is good enough for genealogical purposes, these direct-to-consumer DNA testing companies have been reluctant to adopt WGS technology. But just a couple months ago, MyHeritage made a major announcement. Starting in January 2026, they will be utilizing WGS technology for all of their DNA kits. And the price of their tests will not change, meaning you can get a WGS test for as low as $25 or $30. How is this possible? Well, the key here is that MyHeritage will be utilizing a low-pass sequencing WGS test of only 2 times coverage. There will be plenty of errors that result from such a low coverage test. But MyHeritage is confident that even at such a low coverage level, that they will see significant improvements in their matching algorithm and ethnicity estimate over time. Genetic genealogists are excited about the possibilities of the introduction of this new technology to consumers. And it will be interesting to see if this leads to other DNA companies adopting the WGS technology as well. So how does all of this relate to Y-DNA testing? Remember that WGS testing in men includes testing of their Y chromosome. This means, in theory, WGS testing can be used to identify SNPs on the Y chromosome, just as family tree DNA's Big Y test does. If WGS testing becomes ubiquitous, there could be multiple testing companies that can offer detailed Y-DNA haplogroup assignments as part of their offering. Imagine if Ancestry, MyHeritage, and 23andMe were able to provide Big Y block trees similar to family tree DNA. Or that you are able to take the WGS data from these mainstream autosomal DNA testing sites and upload it to family tree DNA or YFOLS databases to receive a detailed haplogroup assignment. This has the potential to be a major catalyst for more widespread adoption of Y-DNA testing that could accelerate the build-out of phylogenetic trees. But all of this possibility comes with a very important caveat. With Y-DNA testing, you need to be extra certain that the position you are reading is correct and that it is not an error. After all, the Big Y test is meant to identify private variants that aren't found in any other tester. So in order to ensure accuracy, a Y-DNA test needs to be of very high coverage. For example, family tree DNA's Big Y test has 70 times coverage, far above the 30 times coverage seen in clinical grade WGS tests. What this means is that MyHeritage's announcement of their low pass, 2 times coverage WGS test is unlikely to be very useful for Y-DNA purposes at the present time. But perhaps there will be a time in the not-so-distant future when the price of WGS testing comes down further to allow for higher coverage WGS consumer DNA tests. In that scenario, it will only be a matter of time until higher coverage WGS testing becomes the standard for DNA testing, and its arrival will transform our understanding of Y-DNA lineages. Prediction number 3. Big Y testing will continue to steadily increase, leading to an acceleration in discoveries. This last prediction is less heroic, but it is an important one nonetheless. Since Family Tree DNA introduced its Big Y700 test in early 2019, it has seen a significant increase in the amount of newly discovered haplogroups, averaging around 12,000 new branches every year. My expectation is that this steady pace of growth should continue over the next few years. Unlike the autosomal DNA testing companies, which saw a huge spike in testing for a number of years, followed by a rapid decline once most people had tested, Family Tree DNA's Y-DNA testing is far earlier in the adoption curve. Most people still have not had a family member take a Y-DNA test, and there is no reason to believe that Family Tree DNA's growth will slow down. In fact, it is my impression that the growth in Y-DNA lineages each year is somewhat capacity constrained. This is because Family Tree DNA's processing times sometimes get elongated during times of higher demand. Given the amount of manual work that is involved with processing Big Y kits, there's only so much that Family Tree DNA can do week in and week out to process these kits. My claim is that this steady pace of growth should lead to an acceleration in discoveries. Why would that be? One reason is that as awareness of Y-DNA testing grows, I would expect testing to increase in areas of the world that are currently underrepresented. This includes many areas of the world outside of North America and Western Europe. Testers from these regions are more likely to have differentiated Y-DNA haplogroups than others that have already been well studied. And so, as more of these individuals receive their results, this should lead to significant refinements of rarer haplogroups. Testing undersampled populations can also lead to interesting discoveries where connections are found between testers from disparate geographies. My own Y-DNA lineage is a good example. Some of my closest Y-DNA matches, going back a few thousand years, are from Afghanistan and Pakistan, far away from my own lineage, which likely was in Western Europe for at least the past 1,000 years. These are among the most exciting discoveries, as they can help reveal hidden migration patterns that otherwise would have gone unnoticed. Another reason comes down to scale. As more testers enter Family Tree DNA's database and the Big Y block tree gets built out, it will get easier for new testers to find closer matches, perhaps even within a genealogical time frame. The autosomal DNA testing databases are a great illustration of the benefits of scale. Early on, when companies like Ancestry and 23andMe began selling DNA kits, the people who tested wouldn't find any noteworthy relatives in their match list. This is because their databases were still very small, and there weren't enough testers to make their match list meaningful. But this changed a few years later when DNA testing became popular. Nowadays, if you are a tester from a well-sampled population, let's say you have colonial American or British ancestry, you are very likely to have a robust match list with close relatives that you already know and others that you may not, but are close enough matches that you can discover how you are connected. I think a similar dynamic can play out with Family Tree DNA's Y-DNA database over time. The match lists will get more meaningful as the database grows. And your odds of finding connections within a genealogical timeframe are going to increase. The need for targeted testing might even diminish once enough people have tested. And when that day comes, it will be great because targeted testing is really challenging. With each additional Y-DNA kit, the road ahead will get easier. As you can tell, I am quite optimistic about the outlook for Y-DNA testing over the coming years. The addition of ancient DNA samples, adoption of WGS testing technology, and steady growth in Big Y testing should lead to an acceleration in discoveries spanning lineages across the world. Let's help make this future a reality. Start with yourself or a close relative and take a Y-DNA test. And then, once you've done this, look to extend the research of that surname through targeted testing, or have other surnames in your ancestry tested. Perhaps there will be a day in the not-so-distant future where most families in the world are represented in the Big Y block tree or another Y-DNA database. You can help bring that vision of the future closer to reality, one Y-DNA test at a time. What do you think of my predictions for the future of Y-DNA testing? And do you have any predictions of your own? I'd love to hear about them down in the comments. And if you're enjoying the series, be sure to like and subscribe. Let's keep decoding your Y-DNA together.